Hey everyone, in today's video, I'm going to be showing you how you can speed up your web scraper from taking minutes or even hours to getting it down to seconds. Let's get straight into it. Alright, for this all to make sense, we have to cover a few different topics. So in Python, when you're making requests, let's say you're making requests to some API, you're probably doing that synchronously if you're not sure what async is. Essentially what that means is if we're fetching, let's say 3 links, we're going to do link A, we're going to wait for this to finish, then we're going to get link B. We're going to wait for this to finish, then we're going to get link C, then we're going to return the data. With async, what we can do is instead, we can have A, just start, B, just start, and then C, just start, and then we collect all these results at the end with all our data. So essentially, synchronous goes in line, A, B, C. Async just starts A, just starts B, just starts C. Now, this difference can be massive. For example, in my own mobile application, which I showed in a previous video, by going from sync to async, I was able to take the response time down from 30 seconds on average to under 2 seconds on average. And most of the time it's actually closer to 1. So now that we have this high level overview explained, let's dive into the code. All right, to give a better explanation and to show what the difference really is, let's look at some code. And so for this example, I have this synchronous request pulled up. So we're importing request, inputting time. We're going to fetch these URLs. This is just from Hacker News, common news website for programmers. And we're just going to get each of the URLs in the list from 8,000 to 9,000. So 1,000 URLs. We're going to print out the index that we're fetching. If we get 200, append it to the response, but it doesn't really matter. And then we're going to end the time, and we're just going to call it here. So this is standard request format if you're scraping Hacker News. Code looks good, but it can be much better. And to do that, we can use the async IO and AIO HTTP libraries. These are 2 async libraries that allow us to write asynchronous code, which in the example I showed you, will allow us to create workers that can go out and do each task independently. And we'll be able to time and see the difference between the 2 libraries. Now that we're on the async file, we can see it's a little bit different. For example, we have this fetch URL function, which delegates that specific task, and we function it out so that each worker can do it. Whereas in the synchronous code, we just go through and fetch URLs in succession, and we don't have to really define it. So we have to define this on its own so each worker could do it. Next, we have the main async function. We have results, we have our start time. Then, as you can see, we're doing async with AIO HTTP client session as session. So what this is doing is it's creating a session, and we're going to have our tasks in this list. And then for each URL, we're creating a task that's going to get done by a worker, and we're going to append that task. And so what this is doing is each worker is going to get a task, go do it. Then once they're all done, we're going to pool it all together. And the way this happens is with the results await async.io.gather, and we're going to gather all these tasks. Then we're going to end time, we're going to print it, and we're going to see the results, and then we're going to call it. So those are the main differences with the async code. As you can see, we define our functions with async, so we have to define them as async. And then when we're calling those async functions, we have to say await async io.gather, and let's see what's another example. Await fetch URLs async. So this is a common pattern that you'll see outside of Python as well. When I'm writing Swift code, I also use async await. It's just a common way of writing asynchronous code that allows your programs to be much, much faster. Now that we've gone through both files, let's actually see what the difference is by running the code. So I'm going to open up my terminal, and let's first run the synchronous file. So you can see it's fetching each one synchronously. Now let's run async. And there you go. In 1.22 seconds, we got 1,000 results. And if we go back to the synchronous one, it's still going along. Now imagine you have these 1,000 URLs, and for each URL, you're doing some data processing. So you're not just fetching it and pasting the results into one thing. You're fetching it, doing some data processing, changing something else. And now in this example, this would be so much faster. And as you can see, it's already done. 1.22 seconds. I think this is going to take like 5 or 6 minutes. I'm not going to let it run and let it finish. I think you guys get the example. So if you're running or if you're writing request-based code, highly recommend, if you can, to make it asynchronous. There's many different libraries to do that. You can use async IO and or HTTPX. There's a few different libraries. See which one works best for you. Highly recommend looking at that. And for the next example, we're going to look at how to do this if you're scraping with a headful or headless browser. Because this is great if you're doing request-based, but now let's look at an example if you're doing headless or headful browser. All right, we're back on the drawing board, and for this section, we're going to be talking about the differences between headless and headful. So how these compare to request is we're talking directly to the server. We're not actually loading up the page. For headless and headful, we're loading up the page to some extent. So headless, it goes to the page as you would see it on a browser, but it's not actually opening up a Chrome instance physically on your computer. It's just looking at it, and it's not really loading all the same JavaScript, all the same HTML. It's getting like the bare essentials from that page. Headful is it's opening up a new instance of the browser. You're going to see it running on your computer like a new Chrome tab, and it's navigating the page the same way you would. It's just automated. Now that we've discussed that, the main ways we can speed this up from my experience is what I've done is very similar to the async method. When I create my headless or headful scrapers, what I do is I run multiple at the same time. So let's say I have 100 tasks. My handwriting is pretty bad. But let's say I have 100 tasks. What I'll do, instead of having one headless browser go through all of this, oh, my connection cut out. I'll split this up into 25, 25, 25, and 25. So I'll run 4 headless browsers that are scraping the first 25, second 25, third 25, fourth 25. And most of the time, since my Wi-Fi is pretty good, I actually do like 10, 12 at the same time and running this. The reason I don't really push past that is because if I have too many running at once, the web pages load too slow, and then my web scraper may time out, and I may lose results because it timed out and it's saying, oh, there's no data on the page. Well, yeah, because it didn't load. So you have to find the balance of your Wi-Fi and your internet of what works best for you, and also your computer strength and speed. But if you can handle like 50 headless browsers, that'd be awesome, because then you can just have 50 of these workers, each do 2, and that'd be done super fast. So that's how I do it in the headless versus headful state, and I can show you an example of that code now. All right, to show off the headless scraper, we're going to be scraping Hacker News, but this time instead of using the API, we're going to be using the website directly. In my previous videos, I showed how to scrape using the Google Chrome console. So if we go to Elements, let's just make this bigger, and we click on this, as you can see, we have these 2 TR classes. We have a thing submission, and then we have the second one, which talks about the details of the submission. So we're going to be writing Python code, asynchronous, headless Python code to scrape all this. So if we go to our code editor, as you can see, I've already written the code. So what we're going to do is we're going to open up 4 browsers, and those 4 browsers are going to collect the data. So I just made an article class to make this easier and more organized. I actually didn't have to do this because not going to be returning the data since we don't really care. It's more about the example. But so what we're going to do is we're going to extract article info. So I'm using ZenDriver, which is a headless, undetectable Chrome driver. You can use Selenium or other ones. I just tend to use ZenDriver because it's been undetectable and it's really good. But I'm probably going to try other ones out as well, and I'll keep you guys updated on that. But moving to the actual code, what we're doing here is we're just giving the title, the link itself, and then we're also getting the subtext if it's available. Then this is the main asynchronous part. We're getting the page range. So since we're getting the first 10 pages, what we're going to do is we're going to go through each page number, add a small delay to avoid rate limiting, which I can talk about further in another video. But essentially when a user or a client is making a bunch of requests to a server, like let's say hundreds or thousands per second, the server will say you're doing too much and it'll block you temporarily. To avoid that block, we can add our own little rate limit of like I experiment with like 1 to 5 seconds, and you could just see what gets you around that rate limit. And some APIs say directly what the rate limit is, but so that's to get around that. And then we're just going to print browser index is processing this page and it found this many stories, and so on. And then if we get exceptions, put that out. And here we have this code. So we're getting 10 pages, the pages per browser. We're just going to do the number of browsers, and then we're going to do integer division. So this way, if we have 4 browsers, 10, we're not going to have like a half or anything. It's just going to be an integer per browser. Then for each browser, just going to loop through, get the code. Again, await, gather all the tasks, and then we're going to put the timestamp. So this is all great in theory, but now let's see what it actually looks like. So let's go to our terminal and let's run this. So we're going to run our Hacker News headless. And as you can see, it's starting browsers 0, 1, 2, 3, which is the 4 browsers. Each found 30 articles and they're each scraping it with all these different headlines coming out. And I don't think I really need to let this finish because I think you guys get the point. Essentially what we're doing is we're batching the work. And so we have these 4 browsers going, each getting their 30 articles, each scraping their own thing and going. And as you can see, it's getting all these articles, moving on to the next page, getting the next ones, the next ones, the next ones. So if you're scraping, if you're doing request-based, use HTTPX or async.io to make asynchronous requests. If you're going to be doing headless or headful browsing, make sure to set up Selenium or Zendriver in a way that allows you to split up the work, batch the work, and get each item on its own. I hope you guys enjoyed the video. You learned something new. You're going to apply this to your scrapers to make them faster, and I'll see you guys in the next one.